Now, good morning friends. After the discussion of the stationary wave produced in a string tied at the both end and also closed pipe and open pipe. Now, due to the change in the intensity of the sound wave, when the two waves are supposed having the same amplitude and same angular frequency. So, increase in intensity of the sound and decrease in intensity of the sound is possible, and that is known as the beat. Now today we are going to discuss about the beat and obtain the equation of beat produced in unit time. That is also important question, and also the 1 marks objective question frequently asked in good set and NEET exam from this portion. Now first, what is the beat? The beat, that means the phenomena of varying of the sound intensity when the two waves of nearly same frequency and amplitude traveling in the same direction and superposed on each other. When the two waves having the nearly same frequency and amplitude traveling in the same direction, during this propagation they are superposed on each other. During the superposition, the sound are slightly varying, and that is known as the beat. Right? Again, the phenomena of varying of sound intensity when the two waves of nearly same frequency and amplitude are traveling in same direction and superposed on each other, that is known as beat. Now the definition of the beat is quite lengthy, but yes, we keep the clear concept in our mind with the picture, so we can easily keep in mind. The phenomena of varying of sound intensity when the two waves of nearly same frequency and same amplitude traveling in same direction and superposed on each other is known as the beat. Clear this? Okay. Now, beat is produced due to increase in intensity of sound once and decrease once. So again, the beat is produced due to increase in intensity once and decrease in intensity of sound once. Right? Number of the beat in 1 second is known as the frequency. Frequency of the beat is difference of the two near frequency. Our aim is to obtain the numbers of the beat produced in unit time. Therefore, the number of beat in unit time, actually that is the frequency. And the frequency of the beat is difference of the two near frequency. So in short, we have to obtain the equation of the frequency of the beat. Again, we repeat the definition of the beat. The phenomena of varying of sound intensity when the two waves of nearly same frequency and amplitude traveling in same direction and superposed on each other is called beat. Now, beat is produced due to increase in intensity of the sound once and decrease once. So how the beat is produced? If the one times the intensity of the sound becomes the maximum and then minimum. So one beat is produced. Right? Number of beat in 1 second is called frequency. And frequency of the beat is the difference of the frequencies near frequency. Here the two waves traveling the same direction with the nearly same angular frequencies. Therefore, both waves should have very close near frequency. The difference of this frequency then gives the frequency of the beat. That means there is the number of beat produced in unit time. Okay. To obtain the equation of number of beat in unit time, we consider the equation of the transverse harmonic wave. That is the yxt is equal to a sine kx minus omega t plus phi. phi is the initial phase, omega is the angular frequency, k is the wave vector, x is the position of a medium, and t is the time. And a is the, again, the equation of the transverse harmonic wave is yxt is equal to a sine kx minus omega t plus phi. That is our equation 1. Harmonic waves are required for the beat. To produce the beat, the harmonic wave is required, not the transverse wave. Right? Therefore, we take the yxt as s, that means the displacement. X is equal to 0 and initial phase phi is equal to pi by 2 in this equation. Therefore, our equation reduced to displacement s is equal to a sine k. Instead of the x, we take the 0. Minus omega t plus pi by 2. K term is cancelled, therefore omega t minus pi by 2. So that gives the cos. Instead of the sine, now the cos is obtained. Therefore, the equation of the harmonic wave S is equal to A cos omega t. That is the equation of the harmonic wave. For beat, we require the two harmonic waves with nearly equal angular frequency and amplitude. Therefore, the displacement of two harmonic waves of nearly same displacement and angular frequencies. Therefore, S1 is equal to A cos omega 1t and S2 is equal to A cos omega 2t. So these equations are the equation of the two harmonic waves, slightly near angular frequency and slightly near displacement or the amplitude. Clear this? Okay. These two waves are traveling in same direction, and during this propagation, they are superposed on each other. Therefore, the resultant displacement of the wave from the principle of superposition, the resultant displacement is S is equal to S1 plus S2. Already we know the principle of the superposition, right? The resultant displacement is the vector sum of displacement of individual waves. Therefore, S is equal to S1 plus S2. Now, S1 is equal to A cos omega 1t plus S2 A cos omega 2t. A is common, therefore, cos omega 1t plus A cos omega 2t. We can add A cos omega 1t plus cos omega 2t. Now, cos plus cos, 2 cos cos. That is the standard equation of the trigonometry. Right? Therefore, cos c plus cos d is equal to 2 cos c plus d by 2 into cos c minus d by 2. C is omega 1, d is omega 2t. Therefore, this equation turns like this way. S is equal to 2a cos omega 1 plus omega 2 by 2, right, into cos omega 1 minus omega 2 by 2 into t. This again, we are applying this equation. Cos c plus cos d is equal to 2 cos c plus d by 2 into cos c minus d by 2. Omega 1 is our c, omega 2 is our d. Therefore, S is equal to 2a into bracket cos omega 1 plus omega 2 by 2 into t, t is common, into cos omega 1 minus omega 2 by 2 into t. Now, this omega 1 plus omega 2 by 2 is considered as omega a, and that is considered as omega b. Therefore, our equation S is equal to 2a cos omega a t into cos omega b into t, where omega a is equal to omega 1 plus omega 2 by 2. And omega b is equal to omega 1 minus omega 2 by 2. What is the omega a? Omega is the angular frequency of amplitude. Actually, this term represents the amplitude of resultant wave. Therefore, omega a is angular frequency of amplitude, and omega b is the angular frequency of beat. Omega b is angular frequency of beat, and angular frequency of the beat is omega 1 minus omega 2 upon 2. Now, condition is that if omega 1 minus omega 2 is very much less than of omega 1 or omega 2, and therefore omega a is greater than omega b. That means the angular frequency of amplitude is greater than the angular frequency of beat. Okay. Then resultant wave is oscillating with average angular frequency omega e. Now the amplitude of resultant wave cos omega b into t varies with time. There is the angular frequency of a beat. Therefore, the amplitude of cos resultant wave cos omega b into t varies with time. Omega, yes, so amplitude is varies with time. For maximum amplitude, cos omega b t is equal to 1 actually, because for amplitude we take the angular frequency as omega I, not b. Therefore, intensity of the resultant wave increases and decreases per 2 Vb is equal to omega 1 minus omega 2. But the omega is equal to 2 pi f. 2 pi f. Therefore, f of beat is equal to f1 minus f2. Thus, the amplitude of the beat becomes maximum and minimum for f1 minus f2 times. So here this theoretical part is quite complicated if we understand the equation. S is equal to 2a cos omega a t into cos omega b into t. Actually, the omega is the amplitude of, is the angular frequency of the amplitude, and omega b is the angular frequency of a beat. Right? Therefore, amplitude of resultant wave cos omega a t varies with time because that is also the function of time. For maximum amplitude, cos omega a t must be equal to 1. And intensity of the resultant wave increases and decreases per cos omega b into t. Therefore, 2 omega b is equal to omega 1 minus omega 2. Because the omega b is equal to omega 1 minus omega 2 by 2, 2 is taken this side. Therefore, 2 omega b is equal to omega 1 minus omega 2. But we know that the angular frequency omega is equal to 2 pi f. Therefore, 2 pi f is cancelled, 2 pi cancel. Therefore, frequency of the beat is equal to f1 minus f2. Thus, the amplitude of the beat becomes maximum and minimum f1 minus f2 times. Clear? Again, we repeat the answer of this question. What is the beat? The phenomena of wavering of sound intensity when the two waves of nearly same frequency and amplitude traveling in the same direction and superposed on each other is called beat. Again, the phenomena of wavering of sound intensity. Right? When the two waves of nearly same frequency and amplitude traveling in same direction and superposed on each other is called the beat. Beat is produced due to increase in intensity of the sound once and decrease once. What is the beat? Number of the beat in 1 second is called the frequency. Frequency of the beat is difference of two near frequency. We want to obtain the equation of number of beat in unit time. That means we want to obtain the frequency of the beat. Now, for that purpose, consider the transverse harmonic wave yxt is equal to a sine kx minus omega t plus phi. Phi is the initial phase, omega is the angular frequency, k is the wave vector. But for beat, the harmonic waves are required. Therefore, in above equation, we take, instead of the y, we take the displacement s. X is taken as 0 and phi is equal to pi by 2. Therefore, our equation is changed. S is equal to a sine k into 0 minus omega t plus pi by 2. This term is cancelled. Therefore, a sine minus omega t plus pi by 2. Therefore, sine function changed to the cos, because the pi by 2 minus theta. Therefore, cos theta. Therefore, S is equal to a cos omega t. Now, displacement of two harmonic waves of nearly same displacement and angular frequency are S1 is equal to a cos omega 1 t, and second equation S2 is equal to a cos omega 2 into t. These two waves are traveling in same direction and superposed. Therefore, from principle of superposition, the resultant displacement S is equal to S1 plus S2. We substitute the value of S1 and S2, a cos omega 1 t plus a cos omega 2 t. A is common, cos omega 1 t plus cos omega 2 into t. Now we know that cos c plus cos t, 2 cos c plus d by 2 into cos c minus d by 2. Using this equation, so our equation is S is equal to 2a. Now, cos omega 1 plus omega 2 by 2 into t into cos omega 1 minus omega 2 by 2 into t. Here we take the omega 1 plus omega 2 upon 2 as omega n is the angular frequency of amplitude, and omega 1 minus omega 2 by 2 as the omega b is the angular frequency of the beat. Because this equation is same as the y is equal to a cos omega t, a is the amplitude, so here this part is the amplitude of resultant wave. Therefore, omega is the angular frequency of amplitude, omega b is the angular frequency of a beat. Now, if omega 1 minus omega 2 less than omega 1 or omega 2 and omega a is greater than omega b, then resultant wave is oscillating with a wave angular frequency omega a. Therefore, amplitude of resultant wave cos omega a t varies with time. Now, for maximum amplitude, cos omega a t is equal to 1. Therefore, intensity of the resultant wave increases and decreases per 2 omega b is equal to omega 1 minus omega 2. But omega is equal to 2 pi f. Therefore, f of b is equal to f1 minus f2. Thus, amplitude of the beat becomes maximum and minimum f1 minus f2 times. Clear this? So that is the concept of the beat and the number of beat produced in unit time. Clear? So here the most part of the theory of this chapter waves are completed. Clear?